Okay, so we are working through question 3 here. Let's give it a read. It says a horizontal bridge positioned 5 meters above level ground is 110 meters in length. The bridge also touches the top of 3 arches. Each arch begins and ends at ground level. The arches are 5 meters apart at the base, as shown in the diagram below. Let x be the horizontal distance in meters from the left side of the bridge, and let y be the height in meters above ground level. So here is a diagram of what we have just been described. We have a bridge right here, which is 110 meters. It is 5 meters from the ground. It touches 3 arches, and the arches are 5 meters apart from each other. Then here we're told that arch 1 can be modeled by the function this right here, arch 2 by this, and arch 3 by this. As you can see, we have specific domains for each of them, and we have here A being there, and there's an A there as well. What does that mean? Well, for the very first thing, we're asked to state the value of A, where A is a real number. So we need to figure out what this A is. Well, as you can see here, A is in the same position as this 40, is in the same position as this 5. So too over here, this A is the same position as the 40, same position as the 5. So we can figure out what this is by looking at our graph, and let me grab a pen here. As you can see here, this is starting at 5, and I have a 5 there, so it's just causing a translation 5 units to the right. So to here, I have a 40 there, and I have a 40 there. It's causing it 40 units to the right. So when I come here, I know that these arches are 5 meters apart from each other. So if this is 70, this is going to be 75, and that's going to mean that A is equal to 75. It's only worth 1 mark, so I just need that answer. If I come and look at my examiner's report here, I can see that 95% of students got this 1 mark. A is equal to 75. This question was answered well. Let's close that up and go on to our next question, which says describe the, and I'm going to highlight this word, describe the transformation that maps the graph of y equals this to y equals this. So I'm trying to get arch 2 to become arch 3. How can I figure this out? So I'm going to grab my pen. So what I'm doing here is I need to figure out how can I make arch 2 into arch 3. Well, they look and they are identical based on their functions. The only difference is that this is to the left. So what I'm going to do is I'm going to move it to the right. Now this is 40 and this is 75. So I need to move it 35 meters right. And by doing that, they're going to become the same thing. So I'm going to come down here and I'm going to grab a black pen and I'm going to say, we are going to perform a translation of 35 meters, 35 meters to the right. That is what we're going to do. It's only worth 1 mark. Let's look at our examiner's report here. As you can see, 78% of students got the full 1 mark here, translation of 35 meters to the right. This question was answered well. Some students wrote 35 meters to the right, omitting translation. That word is very important because it asked us for a transformation. So the transformation in this is a translation. So we have to make sure that we actually state it. A few wrote to the left or 5 meters to the left or right. Some students had a correct statement followed by an incorrect expression such as this. So the real take-home message there is be careful of what you're writing, and if it asks for a transformation, make sure you give them one, in this case, a translation. Okay, let's keep on moving. The area above ground level between the arches and the bridges is filled with stone. The stone is represented by the shaded region shown in the diagram below. So this shaded region here is the stone. Okay, so what do we have to do here? C. Find the total area of the shaded regions correct to the nearest square meter. Okay, so how are we going to approach this? We need to find it. The very first thing that I'm going to notice is that I'm dealing with area and I see a rectangle. I quite clearly see a rectangle here. This is a rectangle. And the area of this rectangle is going to be a height of 5 and a length of 110. So if I multiply those together, I'm going to figure out the area of this rectangle. So we could say that this is the total area underneath the bridge. So total area under bridge is going to be equal to 5 times 110, which is going to be 550 meters squared. The next thing I'm going to do is I'm going to find the area underneath each of the arches. So all together, so the total area under arches. So I'm going to write total area under arches. To find this, I'm going to have to use my integral. Now, all these arches are identical. They're just shifted left or right. So if I find it for one and then simply multiply it, I'm going to be fine. So let's figure out what the function for arch 1 is. So that was given to us up here. I'm going to come here, I'm going to open this up, and I'm going to define this. So h1 of x is going to be control this 5 times sine of control that, open my brackets, x minus 5. Remember how to get your pi. Then bring that down, make that 30, come over here, close my brackets. I'm now going to restrict my domain so that my domain is between 5, control that is less than or equal to x, control that is less than or equal to 35. I hit that. And now what I'm going to do is I'm going to go shift plus to bring up my integral sign. I'm going 5 to 35 of h of 1 of dx, and that is going to be the area underneath arch 1. So if I come down here, that is the area underneath arch 1, but remember I want the total area under arches, so I'm going to multiply this by 3. So I'm going to go 3 multiplied by this, which is going to be 900 pi. So just to write out what I did there, I'm going from 35 to 5 for h1 of x dx is equal to 900 pi. Then I'm going to grab my black pen and I'm going to say that the shaded area is going to be equal to, and let's zoom in here, 550. And actually, let me just come up here for a second. Let me put meters squared there. Minus 900 over pi is going to be equal to, now I'm going to come here, I'm going to come here, I'm going to go 550 minus this, and then I'm going to go control equals 263.521. It says to the nearest square meter, so it's going to be 5, sorry, it's going to be 2, it's going to be 264 meters squared. That is going to be our answer. Let's come and look at our examiner's report here to see how we did. Sure enough, that is our answer, 264 meters squared. As you can see, they did the same working out as us. 66% of students got the full 1 mark here. 3 marks here, so there's 3 marks here, sorry. The question was answered reasonably well. There were some rounding errors. Some students had the correct expression, but the incorrect answer. Others had the incorrect terminals for the area of the arch. For example, this. Some students left their answer as that, so they did not read the fact that you needed it to the nearest square meter. Okay, perfect. Here, let's read this now. A second bridge has a height of 5 meters above the ground at its leftmost point and is inclined at a constant angle of elevation of this right here, as shown in the diagram below. The second bridge also has 3 arches below it, which are identical to the arches below the first bridge. So that's important. They're identical to the arches below the first bridge and span a horizontal distance of 110 meters. Let x be the horizontal distance in meters from left to right of the second bridge, and let y be the height in meters above ground level. So what has changed here is simply we have a second bridge which is elevated by this angle right here. The first thing that we need to do is state the gradient of the second bridge correct to 3 decimal places. So we need to state the gradient of this second bridge right here. In order to do that, we're going to have to use this angle right here. The gradient is simply going to be tan of that angle right there. The reason why that is going to be the case is because, remember, your gradient, what is your gradient? Your gradient is your rise over your run, right? And if we think about this for a minute, Sakatoa, this is going to be my hypotenuse, this is going to be my opposite, this is going to be my adjacent. So if we use rise and run, that means we're looking at the opposite over adjacent. So tan of pi on 90 will give me the opposite over adjacent, which, hey presto, will give me my answer. All right, so we're going to come over here. I'm going to go that, I'm going to go tan, and I'm going to go shift, divide. Then I'm going to hit that, then I'm going to hit pi, then I'm going to come down, I'm going to go 90, and I want my answer correct to 3 decimal places, so I'm going to go control equals, and I'm going to get 0.0349, which means my answer is going to be 0.035. That is the ugliest 5 I've ever done seen. All right, let's do that. Let's come here. Let's come here, 0.035. 61% of students got this correct. This question was generally well answered. Some students evaluated pi on 90 or sine pi on 90. There were some rounding errors, and 0.036 was sometimes given. Okay, so that looks pretty good to me. Let's get rid of this because that isn't necessary. Okay, let's go to our next question, and let me minimize this. Okay, P is a point on arch 5. The tangent of arch 5 at point P has the same gradient as the second bridge. Okay, find the coordinates of P correct to 2 decimal places. So let's come up here and just kind of reflect upon what we're being told. We have this point P, and we know that the tangent is going to be, have the same gradient as this. Now we just figured out the gradient of this. We just said the gradient of this is going to be tan pi on 90. That is the gradient of the bridge. So that means that is also the gradient of the tangent here. It's also that. So if I now want to find the coordinate of P, what I'm going to do is I'm going to take arch 5, I'm going to differentiate it, set it equal to this gradient, and solve for x. Now I know arch 5 is the same as my second arch, and my second arch is given right here. So that means, actually let me write out what I'm going to do first. So what I'm going to do is I'm going to differentiate h2 of x, and I'm going to set that equal to tan on pi on 90. And by doing that, I'm going to figure out what my x is going to be equal to, and then once I figured out what my x is, then I can figure out what the y is going to be. So I'm going to have to come up and figure out what, go all the way to the top. It's this one I'm dealing with right here, h2. Okay, so I'm going to cheat a little bit. I'm going to come to h1, which has previously been defined. I'm going to change that to 2, and then I'm going to change this to 40 because there's a 40 there, and I also have to change this to 40, and I'm going to have to change this to 70, like so. Now I hit enter, that's done. So now what I'm going to do, let me come all the way down here so I can immediately write down what my answer is going to be. Here I am. I'm going to go, well, I'm going to solve. So I'm going to go menu, algebra, and I'm going to solve shift minus x of h of 2 of x, which is going to be equal to this right here, and I'm going to solve it for my x values, and I want this correct to 2 decimal places, so I'm going to go control enter, and I'm going to get 54.3626, and remember I also need this as coordinates, so I'm going to have to put this into that to get my y coordinate out. So this is going to be 54.3626. Now as you can see here, no, that's good. All right, and then what I'm going to do is I'm going to go h of 2 is 54.3626, which is going to be equal to 49887. Now I need to give my answer to 2 decimal places, so it's going to be 54.36. Whoops, I forgot the dot. That ain't good. 4.9887. So this is going to be 4.99, like that. Perfect. Let's look at our examiner's report here. So as you can see here, they differentiated h of 2. They set that equal to tan pi on 90. X is equal to that. Then they chucked that into this, and it's equal to 4 that. And then they got that as well. Correct to 2 decimal places. Many students were able to equate their answer to this. Some students were possibly estimating values for the coordinates for the graph, as p of that was sometimes given without working. Okay, So that looks all pretty good to me. Let's close that up. And we're up to the last question now. Let's grab our highlighter. It says, a supporting rod connecting a point Q on the second bridge to point P on arch 5. The rod follows a straight line and runs perpendicular to the second bridge as shown in the diagram on page 18. Find the distance of PQ in meters, correct to 2 decimal places. So we need to find the distance of this thing. All right, so let's just kind of reflect upon what we're being asked to do here. Let's get rid of all of this. What we're being asked to do is find the distance from P to Q. We're being asked to find this right here. Now, in order to find that distance, what I'm going to have to do is I'm going to have to find the equation of the bridge, so the equation of this line, and I'm going to have to find the equation, whoopsie daisy, of this line as well. Let's make this red. Let's just keep it as red. Sorry, I'm getting mixed up with all my colors here. Actually, you know what? Let's make this a different color. I'm getting too hung up on the colors here. I'm going to have to find that. Oh, that works perfectly. I need to find the normal to P. All right, so how are we going to do this? How are we going to do that? Let's get rid of this. Let's come over here and let's first figure out what the equation of the bridge will be. This is pretty easy. We know that we know that the gradient is going to be tan of pi on 90 x. Now I know that my y-intercept is 5, so I can use my gradient intercept form and simply say that that is going to be what it is. Perfect. Now I need to find I need to find what the equation of this is going to be. Now, let me show you the way in which you would do this. We know what a point is. We already know what a point is here. We know that we are dealing with this point right here, which we just figured out was 54.36 and 4.99. So we have a point, and we also know what the gradient of this line is going to be because it is it's perpendicular to this line, which means it's going to be negative 1 over tan of pi on 90. Now, because we also have a point, we can use our gradient point form, which tells us that it's going to be x minus 54.36. Did you just see that thing move? What the? This thing's got a mind of its own, equals y minus, and our other point was 4.99. That is going to be our equation. Okay, so once we've got those, we can then equate those to find what this is going to be. All right, so we've got that, we've got this. We're gonna have to rewrite that. Oh, I shouldn't have done it all up there. Oh well, what is done is done. All right, let's come here, let's get a thing there. Let's just it's a 3 marker, so you want to spend your time, you want to make sure that you're providing nice, good, solid working so you can get these marks. So we know that the gradient of PQ is going to be negative 1 over tan of pi on 90 because it's perpendicular, and we also know that we have the point P in which it goes through, which is going to be 54.36 and 4.99. Based on that information, what we can say is that the equation of PQ is going to be, y is equal to, y minus 4.99 equals, I messed that up again, negative 1 over tan of pi on 90 x, brackets x minus 54.36. Gradient point form, perfect. That's pretty ugly the way it is. We could clean it up. The way in which we would clean it up is we would have to multiply these out and then plus that to the other side. So let me just quickly do that on the CAS. So I'm going to go Control, divide, then I'm going to go negative 1 over this thing right here. And I'm going to multiply that by 54.36. So times, whoopsie daisy, I messed that up, times the negative of 54.36, that one right there. I'm multiplying it by that, which is going to be that, and then I have to plus 5.99 onto it, so that I can get y by itself here. So I'm going to take this and I'm going to plus onto that this thing right here, which is going to give me 1561 that. So that means I'm going to get y is equal to negative 1, or if I wanted to, I could say what is this? Control equals, it's negative 28.63, negative 28.6363x plus 1561.73. Okay, so we just found it now. If you wanted another way to find it, I think it's very important to show that working for those 3 marks, but there is actually a quicker way on the CAS, on the CAS, that you can find this normal line. The way that you could do it is go menu, calculus, normal line, because that's what you're finding, a normal line. You're finding it for h of 2x when my x is going to be equal to 54.36. So let's just come up there and find this for this one right here. And this should give you the same thing. And sure enough, it does. There it is right there. So, oops, I forgot a negative. Negative 2.8636x plus 156.73. So you got the same thing there, but I think it's very important that you show VCAA how you got the working for it. So that's still important. The other thing that you needed to do is show the equation for the bridge. So equation of bridge, that's going to be y is equal to tan pi on 90 x plus 5. Okay, then what you're going to do is you're going to equate to those and solve for x. So we're going to go tan pi on 90 x plus 5 is equal to, you could use either this one or this one. Let's just use, that minus disappeared. Didn't I not have a minus there 2 seconds ago? Minus 28.6363x plus 1561.73. So we're equating those. We're now going to solve that for x. So we're solve for x. If I solve that for x, what I'm going to end up with is menu, algebra, solve. I'm equating this as being equal to this x plus 5 for x is going to give me 54.296. And then remember, we're then going to have to take one of these and sub that back into it to get my y coordinate for the q. So let's take this one right here. I'm going to take this and I'm going to go control this such that my x is equal to that, which is going to give me 6.8960. So this is very important now. What I have just found out is that my q point is 54.296 and 6.89606. Now I am a little bit afraid that I may have lost a few people, not because this is necessarily the hardest thing in the world, but because there's a lot of numbers flying around here and perhaps my working isn't as nice as I would want it to be. What we have just figured out is what this Q value is. We've just figured out what this Q value is, the Q value, and we found that by simply equating these two lines with each other and finding where they intersect. That's all we did there. Nothing too complicated, but I do fear that we kind of got lost in the maths. And hold on tight, because there's more maths to come here, because we now have to find the distance between point Q and point P. We have to find the distance between point P and point Q. So we're finding P to Q. That is what we're finding, everyone. We're finding this distance right here, from here to here. That is what we're doing. So to do that, we're going to have to use our distance formula. Come here, get my black pen. I'm going to be finding the distance of PQ. That means I'm going to be getting a big square root sign and going, all right, I'm going to take 54.296 and subtract that from my x value here, which is 54.36. Then I'm going to square that, and now I'm going to plus that onto 6.89606 minus 4.99, and then square it there. Okay, now I'm going to chuck that all into my CAS. So I'm going to come over here now and go control the square root sign, and I'm going to open my bracket, and I'm going to grab 54.296, which is right there. Whoops. And I'm going to subtract that from 54.36. So I'm going to find that. Where is that? 54 point. There it is. Take that, close my bracket, square that. And then I'm going to plus open bracket 6.86, so this one right here, and I'm going to subtract from that 4.99. So I'm going to come up here to where I have 4.99. Where is it? Where are you? There you are. That one right there. Close my brackets and square that. Okay, that should now take me to the end. I'm going to hit enter, and I'm going to get 1.90836. Now remember, we're giving our answer to correct to one decimal place, so that means my answer is going to be 1.91 meters. 1.91 meters. That right there, everyone, is going to be my answer. Whew. All right, so let's look at the examiner's report here and see how they approached it. So as you can see, 19% of people got the full 3 marks for this. So as you can see here, they have tan of pi and 90x plus 5. So that's the equation of the bridge, which we have right there. And then they have y2. And as you can see, they have used the pointer gradient form right here, which we have up here. And remember, I also showed you how you can immediately get this by using that normal thing on the CAS. They found point Q, which is what we found right here. And then they said the distance P of Q, they used the distance formula. They got 1.91, just as we did here. 1.91 meters, and it was corrected to 2 decimal places. There were a number of other approaches to this question. Many students were able to get the negative reciprocal of their answer to question 3D. So they're referring to the fact that people were able to figure out the negative reciprocal because it was perpendicular. So that one right there. Other students incorrectly thought P was on the line y equals 5 and used a trigonometric ratio to find the distance. Y equals 5. They thought P was on y equals 5. Okay, I think I know what they mean by that. Okay. But overall, that's how you would approach this. Hopefully you found this helpful. We really took our time with this question. It's a great question and really CAS heavy, and just kind of mucking around and fluffing around with the CAS and making sure that all our numbers are correct. But hopefully you found this helpful, and yeah, I'll say goodbye now.